Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm up 125 is on the screen. Let's get started, please. All right. So you should be just about done. You're working on your coordinate plane. We're going to get started, and we're going to have Jay is going to help us out with base 2 for f of negative 1. And Brandon Felix is going to help us with base 10 at f of negative 1. However, as we get there, let me go over number 2. Number 2 is a cubic. It looks like this. And according to this, we need to rewrite it first. Is that correct? So you rewrote this. Show your neighbor what this one looks like without that 2 on the denominator. What does that look like? Then we'll have Courtney Jean enlighten us. What does that look like? G of x equals to what, Courtney Jean? 1 over 2f, yes. X minus 1 cubed plus 3. That is correct. So that means we're moving that where to, everyone? 1 to the right and 3 up. But before we do that, what does this do to the whole thing, everyone? It shrinks it, yes? So it's going to look something like this. And then we're going to move it 1 to the right and 3 up. So it's going to be somewhere right there. Number 1. What you get for number 1? F of 1 at base 2, Jay. Oh, hands if you got that. That is correct, because if we substitute here negative 1, that's 2 to the negative third, and we can't have negative exponents, goes to the denominator, so it would be 1 over 2 to the third, and then this becomes 8. All right, f of negative 1 base 10. What'd you get, Brandon Felix? Okay, I'll come back to you. Yeah, so we're going to substitute that in there. Let me go to this one once again so you can see the process. Distribute the exponent here. That gives us 3 to the what? Negative 4. Distribute that one here, and that gives us b to the what? 12. We can't have this negative exponent, so we send it where? To the denominator. So this becomes 1 over 3 to the 4th, b to the 12. And what is 3 to the 4th? That's 3 times 3 times 3 times 3, which is what? Rylan! 1 over 81, very good. B to the 12. Very close. You did 3 to the 3rd, which is 27, but 3 to the 4th is 81. Let's go. Rylan on the ball. Back to Brandon Felix. What'd you get? F of negative 1 base 10. That is correct. Let's go. Hands if you got that. All right. This one right here, we got a to the x times a to the negative 5, which is a to the x. We can't have this negative exponent over a to the positive 5. Okay? And we're back to inverses. Let's see if we remember how to do inverses. What is the first thing we do? Think about it. Grab your back of the head back here, long-term memory, bring it to the front. What is the first thing we do? Martin! Very good. Change it to y. And that is equal 1/4 x squared. And what is inverses, guys? That we need to leave x by itself. Is that correct? So at this point, we need to get rid of the 1/4. So we need to multiply times 4 both sides. We're left with 4y equals x squared. And what's our last step right there, everyone? Square root. Square root. This cancels that. We're left with square root of 4y equals 2x. However, is that the inverse? No. Tell your neighbor what's going to make it the inverse. Martin, pass someone. Brandon Doherty. What makes it the inverse? What do we need to do? Very good. He said exchange the variables. Very good. This is square root of 4x equals y. Can we leave it in y form? No, Mr. Q. So we got square root of 4x equals to f inverse x. Copy that, please. Make sure you have it. We're coming back to these again. And if you notice, now we're starting to do more with square roots. We're heading in that direction. All right, copy the agenda, please. Agenda, warm-up number 125, rational functions. I'm going to give you two play sheets. They're labeled 413, 414. I'm going to include them in the Nearpod code that I'm going to give you. It's only 4 problems, itty-bitty problems. You're like, oh, snap. Let's go. How was your afternoon yesterday? Good? Yeah? What'd you guys do? Sleep? Yeah. Yep. Uh-oh. Oh. Just for this class. And if they lose, let me think about the opposite. Okay, no consequences. Anyways, let me think about the reverse part of it. It sounds like a, like something doable, right? And when is that? Friday. Oh, so I have time to sleep on it overnight and think about, let's see. Let's go. Ooh, man, I can see the you guys making those touchdowns. Oh, let's go. Let's go. Anyways, copy the code, FLCU6. 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 That's how you're going to get access to the home plate. And by the way, it's being recorded on YouTube, so they're trying to make a deal with me, my students, that if my juniors win for Powder Puff, that they get no more home plate for the rest of the year, and I'm going to think about what would be the consequence if they lose. Woo. Let's go. Man, like washing my car every day sounds like a plan. Let's go. I bring up different cars in every day, right? Anyways, all right. Once again, you need at least 6 coordinate planes. Got 1 more minute to set them up. Our objective for today can write, solve, and graph rational functions. 1 more minute. Give you some time. Go. All right, look up to the screen. Here we go. So we're still in the middle of rationals. Focus, please, because we're about to move on. But today we need to cover one more concept and skill from within rationals. And by now we know the definition. I'm not going to spend time on that. You already have the notes, and you guys are experts. If I was to ask you to share your definition, yes. There it is. From there we went from general rule to rational rule. We know that H and K are asymptotes. Is that correct? So here's our road. Look up to the screen to make sure that you follow. We started with a simple one. F of x, 1 over x, or the negative portion of x. And this is what they look like. And these are the graphs, yes? From there we went to f of x, 1 over x squared, or the negative 1 over x squared. This is what they look like, different ways of writing them, and these are our graphs. So far so good, yes? From there we ended up with these, with the squared on the denominator, no squared, but we needed to do the division, and this is our slant asymptote. So far so good, yes? All right, which brings us to today. Today we're still looking at vertical, horizontal, and slant, but today we're going to be talking about discontinuities. Think about that word. What do you think discontinuity means? Tell your neighbor, discontinuity. What does that mean? Discontinuity. Yeah, it means that it's discontinued or it stops at a certain point. So we're going to be seeing some of that in the graph where it's missing a chunk from the graph. Okay? So, and this is what we call holes in the graph. All right? Copy this one. Example 1, g of x equals x minus 3 over x squared minus 5x plus 6. Copy that? And this is all being recorded, by the way, and they just suggested that if they lose, to add 10 more problems to their final exam. Woo. That's something to think about, right? Woo. Let's go, Minos. We got this. All right, do me a favor. Let's write a couple of steps on the side to the left of, or somewhere if you have space. Step 1. Ready? Step 1, we're going to factor, simplify, and rewrite. Factor, simplify, and rewrite. That's step 1. Step 2, we're going to ID and then put a big 1 like this, and I'll show you what we're going to do with that. Step 3, we need to find our whole and put in parentheses x, g of x. And you'll see that once we get there. And the last step, we're going to, step 4 is graph, and by now we know how to graph using our VA and HA. Simple steps, all right? And I'm going to leave it there so that you guys can follow the steps. So let's get started. It says, rewrite the function and graph, identify the asymptotes and wholes. Okay, so step 1, it says factor, simplify, and rewrite. So let's do that. I'm going to focus just on the fraction. So let's see. Can I simplify, can I factor x minus 3 anymore? No? Anthony, what do you think? No? So therefore, the only factor that we can factor out of this would be what? If we were to factor anything. A 1, so write it as 1, x minus 3. So now we have two factors, the 1 and x minus 3. Next, tell your neighbor how to factor the trinomial. By now your brain should be able to do that. How do we factor that trinomial? 6 and negative 5. What factors of 6 add up to negative 5? Tell your neighbor, factors of 6 that add up to negative 5. Yes, I heard negative 2 and negative 3. That is correct. So we write that, x minus 2, x minus 3. So let's look at our step 1. It said here we factor first. Did we do that already? Yes. Step 2, simplify. Can we simplify this fraction here? Tell your neighbor what to do there. How do we simplify that? Yes, we do what? Giant 1, which is here. And that leaves us with rewriting our equation. What's left? 1 over what? X minus 2. And we're going to label that our g of x. Now, question, look up. Are we able to graph this one now? You're like, oh yeah, that's easy, Mr. Q. Okay, so step 1's done. Before we graph, we already have our equation. Next step, identify the giant 1. Do you guys see where the giant 1 is at? Yes? So guess what? I want you to use red. Right here on the side, we're going to write whole. Whole. What did we take away as a giant 1? X minus 3 and x minus 3. Is that correct? So we're going to write x minus 3 equal to 0. X minus 3 equal to 0. So let's solve. Plus 3 plus 3, x equals 3. So according to step 3, look up, the whole needs an x value and a g of x value. So do we have our x value already? Yes, Mr. Q, that is, the x value is 3. Now we just need the g of x. So look at it. How do we find our g of x? Talk it over to your neighbor. See if you see it. How would we find our g of x? G of x. All right, looks like Jay's got it. Jay's got it. Yeah. Brandon Doherty, how would we find our g of x? Yeah, substitute the x here instead of the other x. Does everybody see that? So watch, underneath here I'm going to write g of x equals 1 over blank minus 2, and instead of x, what am I going to substitute in there? 3. Therefore, g of x equals 1 over, what is 3 minus 2? 1, and what is 1 over 1? 1. So that's my other value here for the whole. Are we there? Okay. So, with that said, we have our whole. Keep that in mind. Here it is, which is 3 minus 3, 1. And now we can graph this. I'm going to bring this over here. G of x equals 1 over x minus 2. So that means we need a VA. X equals, tell your neighbor what the VA is. What is our VA? Bree. 2 is correct. So let's label that here. Let's show our VA right there. There it is. And what is our HA? Look at it. Tell your neighbor what would be our HA, and then Bree's going to pass it to someone. What is our HA? Bree, pass someone. Nito. 0. That is correct because there's nothing here at the end. It's 0, so here's 0. Are we there? All right. Now, before we start graphing, look up. Look at the denominator of this equation, the one that we're graphing. Here's our equation. Let me highlight that. Look at the denominator and tell your neighbor what that graph is going to look like. How's that graph going to look? Show your neighbor with your fingers. How's that graph going to look according to this denominator? All right, how's that graph going to look, Ryland? Yeah, he's throwing some gang signs, careful. So he said like this and like this. Hands, if you agree with that? Yes? Okay, so far so good. However, look up. If we were to graph that here, it would be here and here. Is that correct? So far so good? However, what is this? That there's a hole on our graph. Where's that at? At 3, 1. Where's 3, 1? 3, 1 is right here, so therefore, erase that little spot with red, put a little circle like that, then connect your graph there, and that is our hole on the graph. So what does that mean? That it has all these values for the graph except which one? 3, 1. Let's go. From 1 to 5, how comfortable are you with this? Yeah, we got it? 5, 5, 4. And if you notice, we got everything done. We already know how to do everything. The only thing we're introducing is the whole. So here goes the process one more time. Look up. Step 1, factor, simplify, and rewrite. Did we factor first? Yes. Did we simplify? Yes, our giant 1. We rewrote this right here. There it is. Did we identify the giant 1? Yes, it was x minus 3 and x minus 3. So we take that to write our whole. X minus 3 equal to 0. Solve. X equals 3. There it is. How do we get our g of x? We substitute that to the equation, and that's how we get our g of x. And that is how we identify our whole. All right? I did one with you guys. I'm going to give you another one for you to practice by yourself. Here it is. Example 1Q. G of x equals x plus 2 over x squared plus 3x plus 2. Let's see how you do with that one by yourself. Jacob squared's almost done. Very good. All right. David's almost done. All right, David, let's go. Man, I'm gonna see if I can be there for the powder puff. I'm gonna be doing some cheers, like, what were the cheers they used to do in the past? You can do it, you can do it, you can, you can. You guys still do those, no? Yeah? All right. I'll be like, you can do it, Mitos, you can do it, Mitos, you can. All right, let's go. Woo! All right. Let's see. Get us started. Who went last? Was it Brandon? Oh, Mitos? Was it you? Pass on one, Mitos. Laura, first things first. What do we do with this? You factor it. Very good. So what do you write on the numerator? And the denominator? Power Rangers. 1 and 2. So this is x plus 1 and x plus 2. Hands if you got up to right there so far? Yeah? Okay. Pass them one. Claire, continue. What do I do? Okay, so we need to simplify this before we get to the whole. X plus 2 crosses out, and we rewrite. So what's our new equation? 1 over x plus 1. Hands if you are to right there so far? That is correct. Okay, not bad, not bad. Next, we identify our giant 1, or in other words, we need to find our whole. We need an x value and a g of x value. So what do I write there to get started? Claire, pass someone. Anthony D. What do I write? And we solve. Minus 2 minus 2. X equals negative 2. It goes here. This one right here. Tell your neighbor what to do from there, and then Anthony D is going to pass someone. Pass someone, Anthony. Claire, what do I do with that x value? Into the x of the equation. So g of x equals 1 over blank plus 1. So that is negative 2. So this gives us what, everyone? Negative 2 plus 1 is negative 1. So 1 over negative 1 is what? Negative 1. So that goes right here. So we got our whole done. So now we just need to graph our equation. All right, pass someone. Claire. VA x equals HAY equals. Brandon Darty, x equals. Negative 1 is correct, so plot that there. HAY equals what, Brandon Darty? 0, that is correct. So far, so good? All right, so tell your neighbor what 2 points you're going to use to graph your graph really quick. And then Brandon's going to pass it to someone. Brandon Darty, pass someone. Jacob squared, 2 points. Negative 2, negative 1. 0. 0, negative 1. 0, 0, 1. All right. So far, so good, but what are we forgetting? Tell your neighbor, what are we forgetting? Yes, what is our whole? Negative 2, negative 1. Negative 2, negative 1. Hands, if you got that by yourself? From 1 to 5, how comfortable are you with this? We got it, right? 4, 5, 4, 5. Okay. So far, so good. All right. Copy this one. This is going to be a little bit funner. Let's see how we do with this one. Example 1, super Q. G of x equals x squared plus 7x plus 12 over x squared plus 4x. Copy that. All right. Shall we continue? Here we go. So Jacob squared, he's going to pass it to someone. So tell your neighbor the first step that you would do was that. First step. Then Jacob squared is going to pass to someone. What is the first step we do with that? All right, Jacob squared, pass someone. Jaden? Oh, Jane. What do we do first? Close. Yeah. Factor. So we got 12 and 7. Jay, what factors does 12 add up to 7? 3 and 4. So our factors are x plus 3, x plus 4. All right. Pass it to someone so they can help me with the denominator and factor that one. Jazzy, look at it. What can we factor from each term? Yes, an x. And that leaves us with, if we took out an x, we're left with, yes, x plus 4. Okay, so far. Next, simplify. Pass someone, Jazzy. Maya, what do we do there? A big 1, which is the x plus 4. And now we rewrite our equation. G of x equals x plus 3 over x. You're like, what? What do we do with that? It's kind of weird, isn't it? What do we need on the numerator only? A 1. So think about it. Now that we're there, what do we do? Maya, pass someone. Danny. Danny said you do long division. Very good. So we got x plus 3 divided by x. Very good, Danny. So, what times x gives us 1x? 1, so that is x, subtract, this cancels. We bring down the plus 3, and that's our what? Remainder. Rewrite that, please, so that we can get our new equation. All right, how do we write our answer for this division? Let's see. Martin, go. Hold on, start with the answer. What is the answer to this division? 1 plus 3 over x. So far, so good. Can we have the 3 on the numerator? No, so where does this one go, everyone? To the front. And how about the 1? To the back. So therefore, we end up with 3 fraction x on the denominator, 1 on the numerator, plus 1, and this is g of x. Okay, not bad. Whew. So now that we wrote this, we need our what? Whole. Tell your neighbor what to do to find the whole of that equation. Looks like the Nelly's got it. Of course, Vianney's got it. Very good, Vianney. Let's go with Rebecca. How do we get started to find the whole? Let's go. X plus 4 equals to 0, minus 4 minus 4. X equals negative 4. So that goes right here. Negative 4. All right. From there, how do we find our g of x? G of x. Pass someone, Rebecca. J. How do we find our g of x now that we have negative 4 of x for our whole? Help him out, Anthony D. We need our g of x for the whole. Yeah, substitute the negative 4 for x on our equation. That is correct. So here's our equation. G of x equals 3 times 1 over blank for the x plus 1. And the x, we said it was negative 4 or negative 1/4. So, see, Rylan, help me out. You're like a human calculator. What is 3 times negative 1/4? Very good. Negative 3/4 plus 1 is positive 1/4. So now that we have our g of x, let's write it right here, 1/4. All right, let's get to graphing, yes? All right. So, Jay, pass it to someone so they can help me graph this equation, our new equation right here. Bless you. VAX equals. Danelli. VAX equals. Yes, Brandon Felix, they pass it to you. Zero, that is correct. X equals 0, here we go. So, we got x equals 0. All right, here we go. And our HA, pass someone, HA, y equals what? Danelli, pass someone. Anthony D. 1, that is correct, which is right there. Now, before we graph this, look up, please. What kind of graph do we get? Look at the denominator. It's only an x. Show your neighbor what that graph would look like if it's only an x on the denominator. Yes? So, yeah, like this and like this. So, which means, look up. From here, from the center of both asymptotes, I'll go 1 up, 1 to the right. 1 down, 1 to the left. However, look up. Before you do that, what does this 3 do to those points? Tell your neighbor. What does that 3 do to those points? Martin, what does that 3 do? Is what? Bigger. He said bigger. All right. So yeah, so instead of 1 up, 1 to the right, it's 3 up. 1, 2, 3 up, 1 to the right. So there's my new point. And this one is 3 down. 1, 2, 3, 1 to the left. All right. However, look up. Let's sketch our hole. Where's our hole? -4 and 1/4. So let's go. 1, 2, 3, 4. 1/4 is about right there. So that means my graph should cross through there and through that point right there. Oh, my bad, -4, positive 1/4. Sorry. I did that on purpose, see if you guys were paying attention. There it is. There you go. You know what? Let me ask Rylan a question. Let's see. So Rylan, look at the, where both asymptotes, look up please. Rylan's going to enlighten us right now. Rylan, look at where both asymptotes intersect, which is right here, right? Okay. Question. If there's a hole or our graph is crossing through the hole at, let's see, away from where both asymptotes intersect, if I go 1, 2, 3, 4 to the left and 1/4 down, or 3/4 down, 4 to the left, 3/4 down, what can you conclude on this side? 4 to the right and 3/4 up. So that means instead of putting a hole there, I'm going to put a point right there. Did everybody follow? Here it goes again. Where both asymptotes intersect, we're going to use that as our point of origin. So look at the hole. I go 1, 2, 3, 4 steps to the left and 3/4 down to see our hole. That means there should be, theoretically, a point 4 steps to the right and 3/4 up. There it is. Woo-wee. You're like, Q, just give us some of these on the pop part day. What's that? I'm still gonna sleep on it tonight. All right, from 1 to 5, come through. Are you with this? All right, I'm gonna stop right there. And turn to your neighbor, let them know what would be a good consequence if you guys lose, juniors lose on powder puffs. Tell your neighbor, tell your neighbor, tell your neighbor, not me. Anyways, those of you following on YouTube, get some practice in, please.